Picture this. You're flying over the icy waters of the Arctic, scanning endless waves for a flash of white. Somewhere below, beluga whales glide through the deep, but spotting them? That's another challenge altogether. Enter artificial intelligence. What if a deep learning model could do in hours what once took months? That's exactly what Fisheries and Oceans Canada and Esri Canada set out to accomplish together. Teaching AI to see, in quotes, beluga whales from above. But can technology really tell the difference between a whale and a chunk of ice? And what does this mean for the future of marine conservation? Welcome back to Geographical Thinking. I'm Michelle Brake, and I'll be your guide as we explore ideas, stories, and conversations through the lens of geography. Joining me today is Mohamed Ahmed, a lead data scientist with the education and research team at Esri Canada. He holds a PhD in geography, where his research focused on budgeting marine carbon sink in the Canadian Arctic waters. He's also an adjunct professor in geography at the University of Calgary. In his role at Esri Canada, Mohamed supports both academic and industry researchers in applying spatial data science and AI to solve real-world problems. He regularly delivers guest lectures and workshops at colleges and universities across Canada to showcase the power of geography and GIS technology. Thank you so much for joining me today, Mohamed, and welcome to Geographical Thinking.
Hi, Michelle. Thanks for having me.
How are things going in the education world? I can imagine busy time of year. We're fully into the winter semester. Are we keeping busy?
Yeah, it's really busy. There's a lot of research projects going
Mm,
on now, and of course on AI and machine learning. And yeah, so a lot of things going on in my side here.
okay, sounds like never a dull moment then in your day-to-day
Yeah,
work.
I agree.
Awesome. Well, to get us started, can you give us an overview of the project you've been collaborating with Department of Fisheries and Oceans on?
Sure. Yeah. So the project with Department of Fisheries and Oceans Canada, and DFO in short, was all about using deep learning. It's a form of AI to automatically detect beluga whales from different imagery sources. So DFO had this big archive, thousands of, if not tens of thousands of images from beluga whale surveys. In fact, there is one survey they collected more than 5,000 aerial images in one survey. So traditionally, biologists would go through all these images, try to count whales, which is, as you could imagine, it's time consuming, labor intensive. So our goal in this project was really to develop a deep learning model that could scan these images and identify beluga whales much faster while maintaining the accuracy. So basically, we are thinking about augmenting the biologist's efforts. So in the beginning, I received these hundreds of photos from DFO team that potentially have beluga whales on them. So I went through all these images, tried to create labels, and creating my training data to train my deep learning model. And then I trained a couple of, I would say, vision transformer models. This is kind of like the state of the art in image recognition computer vision tasks to extract features from images. And in this case, we use it to recognize beluga whales in the photos. So I would say the outcome so far is very promising. The AI models that we actually developed was capable of detecting beluga whales with a high degree of accuracy, sometimes reaching up to 88% of accuracy.
Wow.
Yeah, so this was really a big deal for us because it showed that the AI could handle this bulk of the work and do this
Mhm.
in consistent way. So yeah, I hope using this by using this model and others, it will help freeing up the researchers' time to maybe focusing more on analysis and conservation decision rather than spending like this endless hours on manual counting of beluga whales.
Yeah, I can only imagine how much time that would have taken just to sit down and work through everything. Like, even classification takes a while. Thinking about how many images they'd have to go through just to find whales, and whales move around. We can kind of have an idea of patterns. Maybe there's some with collars, but that's a large process to think about. Knowing that this sounds like a really monumental project and has some great applications moving forward with conservation work. How did this collaboration between DFO and Esri Canada come about for this project?
Yeah, so the collaboration, I would say, began somewhat in organically, I would say. So DFO scientist, especially the scientist, a biologist named Brianna Sherbo, and many others of her colleagues at DFO were kind of like looking for solutions to improve their whale monitoring workflow, especially given this sheer volume of imagery that they collected during their surveys. So at the same time, myself and my team at Esri Canada were exploring how to use the GeoAI capabilities within the ArcGIS software and how this could be applied and helping many of our clients. So one of our colleagues at Esri Canada, Clark Lawler, who is actually a senior account manager, he also has a good connection with DFO. So we approached the DFO team, telling them if there is anything we can do to help them. And I would say this was a perfect opportunity to bring our two worlds together. Once we uh, walk, kind of like talked it through, everyone got excited about the possibilities here. We agreed that to undertake a pilot project. So DFO provide us with beluga imagery, and of course it can help us with their expert knowledge about beluga identification. And in also on the other side, I would develop a deep learning model with ArcGIS to detect whales. So I would say it was a good example of how conservations between our colleagues at Esri Canada and talking with our clients can actually spark this collaboration and can, at the end of the day, can make a difference or drive an impact.
Yeah. And it's interesting you say it's a pilot project because we're not looking at pilot whales in this project, but we are looking at beluga whales. I'm wondering, knowing the wide variety of Arctic wildlife, and thank you for humoring me with my whale jokes, why were beluga whales chosen as the focus for this specific study?
Yeah, that's really good question. So we choose beluga whales as the focus of this project for many reasons. First, belugas are really, I would say, a priority species for conservation and research in Canada. There are certain beluga populations are listed as threatened or even endangered by Canadian wildlife authorities. Second, beluga whales turned out to be really an ideal candidate for from a technical perspective. So beluga whales are often called the white whales. So they have this bright white bodies contrast in a strong way with the dark water of the ocean. So this high contrast makes them, in theory, easier to spot in aerial imagery compared to, say, if you are trying to detect a gray or blue whales, because usually they're blending more with dark water. So in many of the images, beluga can appear like a distinct white blob against a darker background, which is make it easy for the deep learning model, I would say, to recognize. They also tend to be kind of like be in groups at the surface. So especially in the summer months during their migration, so you might see dozens of bloggers in one photo. And this is, I would say, is a great scenario, ideal
Yeah.
scenario to testing the model capability for detection all the whales in this imagery. I think the last thing which is really important, the DFO has this rich data sets that is ready to go. So they have been conducting this area surveys for of beluga whales for years. So they have a lot of existing data and have a lot of data. It's really important to train and validate the AI model. So having many examples to see beluga whales in different conditions, especially if you are looking at detecting beluga whale in a clear water, maybe murky water, maybe in different groups, different sizes, if there is sea ice around them. So I would say we choose beluga because they are ecologically important, but also they are kind of well suited for this kind of analysis.
Okay. And that's interesting to hear because thinking about having gone on like whale watching trips as a kid, they're always difficult to pick out whales alongside the ocean. So hearing that the color specifically against the ocean helps makes it stand out makes sense to me. And I know that in this project, there was different types of imagery and capture methods that were used. Can you explain a little bit more about what these were and what impact they had? Did it make it easier for the whales to stand out against the ocean? Is it something else entirely?
Yeah, so for this project, the primary imagery source was aerial photographs that were captured during the whale surveys. So typically, these images were taken from a small aircraft flying over beluga habitats in the Arctic or subarctic waters. And usually, I would say using aerial photography was kind of a common practice in marine mammal research because it allows them for covering large areas in short time. And then they collect these images, and later they can go to the lab and start analyzing them to manually detecting whales. So the clarity of this aerial images was really a big factor in the model success because it's usually flying really low, so the beluga appeared really a distinct white shape compared to the background. However, there are actually challenges when you're working with these photos. The perfect scenario if you have a calm water and perfect lightning, so it's easy to detect whale. But sometimes, as we know, the condition is not always like this in the ocean or the sea. So you can sometimes see turbid water and low contrast situation, and sometimes you have a lot of sea ice around beluga whales that it's make it a little bit challenging to detect. Um, I also got access, beside the aerial imagery, I got access to drone imagery, which is really was, I would say, a higher resolution compared to the aerial imagery, and it helped me to even detect some of the whales that even swimming below the surface of the water, which was really great to see that the model was capable of detecting some of these whales, not just only surfacing at the water, some of them, of course, subsurfacing or swimming under the water. So I would say in the next phase of this project, I see this project have many phases because
Mhm.
it's always there is a lot of data out there. So I'm hoping to use some of these high-res satellite images that the DFO have access to, and then I can fine-tune the models that I used on training using the aerial imagery and drone imagery. So I can use them on the satellite imagery. So this is, I would say, the next step that I'm hoping to do in this project.
Okay. I'm interested to see where it's going to go in the future. Now, thinking about what has been done so far, and you mentioned we see different elements with different cameras and various things. What were some of the biggest challenges in differentiating beluga whales from sea ice and water whitecaps? I can imagine if I'm looking at it from a helicopter, they might all start to look the same after a little bit.
Yeah, this was absolutely one of the toughest challenges I faced when I was working on developing this model. So, as you know, beluga whales are white or maybe light gray if in the case of younger ones.
Mhm.
And when you are looking at a large aerial photo of the ocean, there are other things that can appear white too. And of course, sea ice is the major culprit here in the Arctic water. So you can just see this small chunk of ice floating around the whales. And from high up, it was really a challenge to sometimes to for me visually say what is whale, what is ice. Also, white caps, this foamy crests of waves in a windy day. So it's kind of like you dotted the water with bright patches that can mimic the size and shape of the whales. Sorry, the size and color of beluga in the
Mhm.
photo. So also sunlight reflection can also create this white glare on the water surface that make it sometimes challenging. I call them as this is elements of distractions or causing this false positives. Sometimes a model can delineate them as well. So I tackle this challenge in few ways. So I try to first in training the model, I try to capture as much as variety as I can, so the model can see all this variability when in the training phase. Also I try to actually label this some confusing elements, so I class it to the model, so the model try to actually learn this is ice, this is white cap, so the model can differentiate between whale and ice cap and white caps and ice flows in the imagery. And at the end of the day, I ended up have a couple of models. Of course, this is iterative process. So I ended have two main models: one for open water when there is no ice or calm water condition, and another one when photos have more than 30% of ice or there is a lot of white caps. Um, yeah, so I want to say also, despite all these efforts that I was trying to do to minimize the impact of these distractions or false positives, models are not perfect, right? So
Hmm.
you need to still have human in the loop approach to so the AI can go and flag anything that looked like remotely like beluga, and then human analysts can go and review these flags and try to actually, especially the one with low confidence
Hmm.
coming from the AI model, and they can just like try to minimize this false positive or take these mistakes out.
Okay. It sounds like a great process where it can help you do a lot of the time consuming work, but you still have that human element to confirm. You do parts, you're training it at the start. People are still really important in the AI process, is what I'm hearing. And I'm wondering, how does this AI focused approach compare to a traditional method like manual image reading or crowdsource analysis?
Yeah, so traditionally, DFO, or I would say many other research groups working on this topic, were kind of relying on having skilled human observer to go through each image and try to mark beluga when they see them. So as you could imagine, this is need someone go clicking through thousands of photographs and images, and usually using a magnifying tool and try to counting whales. So it's really incredibly meticulous work, and it's also slow, and it's kind of like associated with human limitation because we're getting tired right after looking at hundreds of images.
Yeah.
So there is this fatigue element there that could impact your accuracy when you try to detect whales from an images. The other, I would say, traditional method that people was using acoustic underwater or acoustic underway and board of ships. So this is basically try to deploy hydrophones, or we can call them underwater microphones, to
Hmm.
continuously record and analyze these marine soundscapes. So try to capture the whale vocalizations in real time. And this is also was great, and many people are still doing that. But could you imagine this is also restricted with areas where the vessels can regularly operate? So this is could be a shipping lanes or research expedition, and this is also means there is certain beluga population, particularly the one in remote regions, maybe will be kind of like underrepresented in acoustic data sets, because unless if you have someone dedicated to this specific group in this remote area to go to study them, they might be missed in your research. So if adding AI there, it can actually accelerate this workflow, so you can process this hundreds of images in the time that take someone to review just maybe few images, right?
Hmm.
So you can see you are actually shortening the time from weeks to maybe hours, so when you're using the AI models,
Wow.
so which is really great. And also the other thing, it's consistent detection. So I feel AI is not getting tired, right? It's gonna go and try to detect the whale with the same standards, which is really important. But as you mentioned before, Michel, this is really important. I believe we are not looking here to replace humans. I think we are here to complement them. I would say the ideal scenario here, we found like AI human partnership. So the AI model can go first, scan the images and try to flag where is whales, and then human can go step in and try to verify and deal with these tricky cases when the model sometimes is confused if this is a whale or not. So
Hmm.
I see this is I see the AI can help and complement the human work there and bring this speed and scalability and consistency when you try to detect whales in the images.
Okay. And I think that makes sense that we can work in partnership, that there's things that it's able to help us with, that not getting tired, or if I am sick or on vacation, the AI can still help move things along on a project. It's not waiting for me to get back from vacation to keep looking at whales. So I think that's an important thing to note there, is that we still work together It's not AI taking over everything I do, just helping me with some of the parts so I can still have vacation time, which I
Mhm.
think is important too.
Yeah.
And I'm wondering, how do you envision deep learning and AI transforming marine conservation efforts in the future? Do you think it's going to play a role in helping us understand the state of the Arctic seas better?
Yeah, I'm very excited about the future of AI in marine conservation, especially in remote and challenging areas or environment like the polar regions, the Arctic and subarctic areas. So, what I did with Beluga in this project, I see it's a kind of a part of a broader trend. In the past 5 to 10 years, conservation research, you started really harness the AI capabilities to do all sort of wildlife detections and monitoring tasks. So going forward, I feel that we will using the power of AI to scale up these efforts. So today we might analyze maybe thousands of images, or tomorrow maybe we'll have access to hundreds of thousands or maybe millions of images. So the AI will play a big role there, including also real time data, right? So you can use AI
Mm.
to work with real time data too. Um, I think also AI is not limited with one species, right? You can actually take this model and go and try to. I use this example in this case to try to detect beluga whales, but I can take this model, fine tuning it, and try to detect another marine mammals, in the same environment, right? So this is kind of like a really a good opportunity too. So in the Arctic, I would say detecting species, habitat, and distribution is really crucial because this is really linked to climate change.
Mhm.
Because due to climate change, the habitat could be changing really quickly, and AI can help researchers to really know where these species are moving, where are they are moving, and how their number are changing in response to this change. And this is can give them a quick feedback, about what is going on in this environment, and try to help them to understand these changes. um, I believe the AI will play a good role into will be integrated really well in the conservation decision making. So once we start trusting these models, right, we start using them to in management actions. So you can, for example, have an AI system monitoring shipping lanes using aerial imageries and detecting where the beluga whales or other species exist, and then you can alert the ship in real time that you try to avoid this area, because reducing the disturbance or maybe the collision risk coming from the ship to the presence of these marine mammals or beluga whales in this case, in this specific area.
Specifically with whales, I know that there's been some past studies around the shipping corridors and when whales are there. So it's great to hear that there might be some ways for us to impact that as well
Yeah.
with some of this research.
Yeah, there's other things I want to say add here, that AI will also help kind of like really democratize the research in a sense. So um, all these techniques is actually became kind of like more user friendly. So you can think about using some of these built-in tools in ArcGIS software. You don't need really a computer science expert to use them, or someone so anyone, you could imagine someone from in the government agency or NGO can go actually capture these images and can start using these tools right away. And Esri try to do some of this work by offering some of these pre-trained deep learning models that really ready for inferencing, so people can go and download them right away and start doing inferencing. And I'm hoping by the end of this project, I will be able to contribute to this community by adding this model to the Living Atlas, so people can use this pre-trained model to detect whales.
Yeah, and I think that's a great shout out as well that there are deep learning models available on the Learning Atlas to play around with and start thinking about how can you use these tools, and great tutorials to also walk through them, because I think it's easy to forget that this stuff is freely accessible. It's out there. We can use
Mhm.
it. Um, I guess that's a great segue into our last point here is, do you have any advice for researchers and GIS professionals looking to do similar work to this project in the future? I know you're based in the academic side of things, so any research papers that you've published that we want to plug here that people could refer to?
Yeah. So yeah, this is a really great question. So I before actually I maybe I can talk about advice, and I'm going to talk about maybe a couple of the things that people can check out that might be
Hmm.
interesting for them at the end of my answer here. So if you're really interested to using AI or GIS to do kind of like related to wildlife conservation or any similar field related to my experience, I would say you need to collaborate closely with a domain expert. So you need to, in this case, I really benefited a lot by partnering with DFO experts, like they really understand the species and the environment we are studying. So you have this knowledge that they can transfer to me. So when I'm actually developing a model, I understand what is actually the limitation and what I should expect. So it was really kind of like really a good for me to have this communication first before start developing my model. The second thing I would say, you need to take your time when you're creating your training data. So the deep learning model is only as good as your data that you're feeding to train your model. So I know this is a daunting task, and it's for me it took a couple of weeks to train by labeling whales, but it's really rewarding at the end of the day. So if you take your time and try to create a high quality training data, it will end to have a high quality model with more accurate, more accuracy at the end of the day. And also try to take advantage of if you have limitation on the data that you have, try to augment your data to maybe rotating them or do some of these tricks to increase the model accuracy. um, the third thing I would say, try to leverage the tools that is available. So I mentioned before, ArcGIS has these tools, have some of these pre-trained models out there. So check out these models, and also you can actually bring this open source libraries, like if you're using TensorFlow or PyTorch, you can actually bring this some of these libraries and to do more customization in the software. So if you are interested in doing that, so I would say you try to spend more of your time focusing on the problem, not just plumbing,
Hmm.
to get your stuff sorted out. And I would say the last things I want to mention here related to people interested in this, try to stay really curious about this topic and keep learning. The AI field is really evolving quickly, and I know you're Michelle aware of this. So there is always new technologies coming out, and so you need to keep your eye on the latest research, and also try to share your findings with either if it's actually good or bad. If you have a success or failures with the community, I think people will benefit from that.
Hmm.
And I'm hoping to do that actually by the end of this project. So I share this with the community. So I feel by following this, what I said so far, I think people can really set themselves to maybe a degree of success. And I want to actually, because we're talking about the state of the Arctic, I want to
Yeah.
just take this opportunity to mention that there is a state of the Arctic report was really released a couple of weeks ago, and I'm honored to be one of the co-authors on this public report that is led by DFO, and it's actually provide valuable insights into the state of the marine ecosystem and biogeochemical and physical trends in the Canadian Arctic. It's really a big comprehensive report, give us a good understanding of the Northern Ocean, and it's a collaborative effort too. There is many people from DFO, Arctic communities, Inuit organization, academia, and non-government organizations. So please, if you have time, check it out. It's called the State of the Arctic Seas in 2023. So if you just Google this, you will find it easily.
No worries. We'll also throw it in our show notes along with a lot of the other great resources we've talked about today. So no one's going to miss out. We'll get some traffic to it for sure. That brings us to the end. Thank you so much for joining us today, Mohammed, and shining some light on the AI side of things and how can we be using it. I know it's not something that we hear a lot about within GIS, like publicly yet, because we're still working on things. We're still developing, we're still figuring out what are our intersections, how do we bring these in. It's being worked on in projects with the government where we're not putting out as many publications quickly. So I think this is a great opportunity to start sharing some of that. As you said, sharing our work is important. So thank you for joining us today.
Thanks for having me, Michelle. And I just want to say I'm a big fan of your podcast, and thanks for having me. And again, for any of one of your listeners, please don't hesitate to reach out or contact me if you have any questions, or my group at Esri Canada. We are happy to support you to embark on this kind of work in the future. So thank you for having me.
Yeah, thank you. And with that, that brings us to a close. From drones to deep learning, this project is transforming how we study Arctic wildlife. With AI helping us track beluga whales faster and more accurately, the future of marine conservation is looking brighter. A huge thank you to Mohamed Ahmed for sharing his insights, and to you, our listeners, for joining us on this journey beneath the ice. Until next time, keep exploring, keep learning, and keep thinking geographically.